For part 2 of this week on our discussion of categorical data, we will look at contingency tables for two categorical variables. So let's look at the Titanic data set again. So as we talked about earlier, in 1912, the Harvard graduate John Jacob Astor and his wife, they boarded the Titanic. He didn't survive, but we might ask, did his wife? Let's examine the Titanic data set again. So this is the data set where the rows are passengers, those are the cases, and the variables, they're characteristics of the passengers. So we have whether or not the respondent or the passenger survived, their gender, their class, what passenger class they were on, and then we also have their name. So let's look at these rows of 11 and 12, and you can see that we have John Jacob Astor and his wife for those two rows. And you can see in the survived column, for the variable survived, John Jacob Astor, he didn't survive, but his wife did. So this raises some questions. He was an upper class man, and so you might wonder, his wife survived, but he didn't. So were men more or less likely to survive than women? If you just look at John Jacob Astor and his wife, which really can be viewed as like a bit of anecdotal data, if you just look at those two rows, you might wonder, well, were men less likely to survive on the Titanic than women, or what was really going on? You might also ask, were upper class passengers, were they more or less likely to survive than lower class passengers? Because if you just look at John Jacob Astor, you might say, well, upper class passengers were less likely to survive. They're more likely to die on the Titanic. So these sort of little bits of observations, they can really guide us or sort of provide an impetus to answering certain questions. But in general, you want to use the full range of the data. You just don't want to look at two rows. And one way to really look at the data and answer these kinds of questions is to use tables and graphs, in particular contingency tables. And so we're going to look at two categorical variables from the Titanic data set to analyze what's going on. A contingency table, it's also called a cross tabulation. It's simply a table of counts or proportions or percentages from two categorical variables. The reason it's called a contingency table is that it can tell us how the cases or the rows of the data set are distributed along each variable, contingent or conditional on one or more categories of the other variable. So that's why it's called a contingency table, and we'll talk about the idea of conditioning in just a moment. So here's a table of counts, a contingency table of counts. Each cell in this contingency table will represent the number of times a particular combination of variable categories occurs in the data set. And the rows of a contingency table of counts, they're the categories for one variable, and the columns are the categories of the other variable. One thing to keep in mind is that the totals for each row and column are given in the margins. So here is a contingency table of counts for surviving the Titanic and passenger class. So these are all observations. The row variable is labeled here, and it's passenger class. Then the column variable is whether or not the person survived. We also have the categories or levels of the variables survived labeled, and then we also have the categories or levels of the variable class. In the middle, you can see that we have cell counts for each combination of the categories of class and survived. For example, if you just look at the row for the level lower and the column for the column yes, for that value of the survived variable, you can see that we have 131 people in our data set who were a passenger in the lower class, yet also survived the Titanic. To give another example, if you look at this cell, we have 103 people in the upper class who in fact didn't survive the Titanic. We can also see that we have marginal totals, because those are the margins, for each of the column variable. And then we also have, for example, in this case, a total of 618. So if you just add up 369, 146, and 103, the different counts of observations for that column, we get that margin total of observations. And then it's the same for the next column. So for this column, we have 427 observations. If you add up 131, 115, and 181, we have 427 people who survived the Titanic in total. In terms of the row margins, these give the total counts for the categories of the row variable, meaning passenger class. So we have 500 people in the lower passenger class, 261 people in the middle passenger class, and 284 people in the upper passenger class. To give an example, we have 369 plus 131, 500 people in the lower class, right? We have 284 in the upper class. All we're doing is we're just adding these row observations. Now this cell in the lower right-hand corner, that will give you the total number of cases in the data set. So here we have 1,045 passengers, right? One thing to keep in mind is that the column totals, they equal the total number of cases. So if you add 618 plus 427, you get 1,045. In a similar way, if you add the row totals, meaning the totals for each level of the class variable, you also get 1,045, the total size of the data set. And finally, if you look at the cells for each combination of the two categorical variables, those counts also equal the total sample size. And that's quite useful. Just to emphasize, the reason these totals in the margins are called marginal totals is because they are in fact written in the margins. Here's an example of the contingency table without margins, and here it is with margins. To just calculate if you're just given the contingency table without the margins, to create the table with the margins, you just add up the counts for each row and for each column. And then the lower right-hand corner is simply adding up the totals in the margins. You might also encounter a contingency table of proportions or percentages. Often it's useful to express a contingency table in this way because people want proportions or percentages when they're looking at these tables. To convert a contingency table of counts or frequencies to a table of proportions is very easy. You just divide each cell in the table by the total number of cases or observations. And then to create a contingency table of percentages from proportions, you just multiply each cell by 100. So here's an example of converting from counts to proportions. All we're doing is we're taking for this cell, we have 181 observations, and we divide by the total number of observations, and we get this proportion of 0.17. And then to convert from proportions to percentages, again, we just multiply the proportions by 100. So 0.17 times 100 is 17%. So we have 17% of passengers on the Titanic who were a member of the upper class and survived the Titanic overall. Now, when you're creating these tables, it's useful to kind of come to conclusions. So what we found from this contingency table of percentages is that most passengers overall, they didn't survive the Titanic. 59% people didn't survive, 41% of people did. So you can see that John Jacob Astor was actually among the majority of passengers on the Titanic because he did not survive. In a similar way, only a minority of passengers were in the lower class. So most people were, in the upper class, most people were in fact a member of the lower class or the middle class. A relatively small percentage were in the upper class. Another sort of conclusion we can make is about the sort of joint combinations of the levels of the two categorical variables. So we can say, for example, that 35% of passengers didn't survive and were a member of the lower class. To give another example, 17% of passengers overall were a member of the upper class and did survive.